given the root of a binary tree, return the level order traversal of its nodes values from left to right, level by level. So we're given this root node here, this root node, and we want to return a two-dimensional array, an array of arrays where every subarray is another level in the tree, and the values of each subarray moved from left to right. So they represent the values of the nodes from left to right in the level, right? Okay, so how exactly do we create an algorithm to solve this? Well, what we're doing is we're actually doing something called breadth first search. We are exploring every node in a level before moving on to the next level, right? We're not looking at 20 and then moving straight to 15. No, we're going through every level, getting all the elements in that level, or exploring all the elements, all the nodes in that level, and then moving on to the next level. And the way to implement a breadth first search solution is by using, these are our levels, is by using a queue. So this is a queue, and a queue is a first in, first out data structure. Basically, let's say that we passed into it 4, 5, and 6 respectively. Then when we dequeue the elements out of our queue, it's going to come out in that same order, 4, 5, and then 6. A real life example of this is like a concession stand, or a movie line stand. I don't know what you call that, but people are in line and waiting to get tickets or to get snacks. The first person in line is the first person that gets served, and then they get served and they move out. Then the next person gets served, and then they finish, and then the third person gets served, right? So that's what a queue is in real life, and it's basically just a line, At least that's what it's called in America. Okay, oops. Okay, so now let's go ahead and actually solve this problem. So the first thing we'll do is we'll create this queue, and we will add our node to it, our first node, which is this root node here. So we add our root node to our queue. This is our first thing we're doing. And then the second thing we want to do is we want to create an empty array that is going to contain all the sub-arrays as we move through our tree. And we'll call this outer array, we'll call it our all levels array, because it's going to include all levels of our tree. Okay, awesome. And all those levels will be represented by their own arrays. Okay, so now let's get into the heart of this algorithm. What do we want to do? Well, the first thing we want to do is we want to open up a while loop of sorts. We want to say, while our queue is not empty, while our queue's length is not 0, we want to do something. So we check, is that true? Is our queue's length not 0? Yes, it is true. It's equal to 1. So we immediately want to do two things. We want to open up a new array that we will eventually push or append to this all levels array. It looks like we're adding it in directly, but really I don't want to write it out here and then write it out again up here. So we're just going to, for sake of laziness, we're just going to have it up here. Even though it's not part of the all levels array, I'll make sure to mention when we actually do add it in here. Okay. So we create this new array, and then we also create some sort of snapshot of the length at this moment, right? So at this moment, we're looking at level 1, and it has 1 value, right? It has 1 value. So we want to create a snapshot. We'll call it queue length, and queue length equals 1, right? Queue length equals 1, and this is our queue. Queues are spelled like this, but we'll just call our queue. Make it nice and simple. Okay, so now what do we want to do? So we opened up our while loop, we added this new array, we took our snapshot of the length. Now what do we want to do? Well, for each node in our level, in our current level, this is representing the amount of nodes at our current level. We want to run some logic on each node at our level, right? So we'll start with 3. 3 is the only node in our level, but we'll start with 3, and we will say, first thing we want to do 2 things to each node. The first thing is add it to our array, our subarray, and then we want to add its left and right nodes to our queue. So we add 9 and we add 20. Okay? And then we delete it from our queue. So we dequeue it. Now imagine if we didn't take this snapshot of our length at the time we did. Then we would have, if we had set our for loop to be less than queue.length, we would have kept going here. We would have kept iterating and kept adding these values to the wrong array, to the wrong subarray. So that's why this is so important, so massively important, this queue length. And okay, so now we popped out of our for loop, right? Because it was only meant to loop one time. And we then append or push our subarray onto our all levels array. Okay, great. And what do? We pop back up to the top of the while loop. So here we are, we're at the top of the while loop, and we say, is the length of queue not equal to 0? Yes, it is not equal to 0. It's equal to 2. So what we'll do is we'll create a new array. We have values to push, and we will reset the value of our queue length to equal 2. Why? Because there's 2 nodes. There's 2 nodes at this level. And so basically it's during our for loop, that we add new values to our queue, which will then get their length set at the top of the while loop. So it's almost this autonomous nature of how we're setting our counter for each level. It's a little unusual if you're not used to it. Okay. So now we have our queue length of 2 representing our two nodes at this level, and we want to run our logic on these 2 nodes. So first thing we do is we start with 9, and we add 9's value to our array, and then we add its left and right values, or its left and right nodes, to our queue. But since they are both null, we are choosing not to add them to our queue. We don't want to add them if they're null to our queue. They have no purpose. They're not in our output, so we won't add them to our queue. Then we delete 9 off of our queue. We dequeue it, and we move on to the second iteration of our for loop, and we iterate on to 20, right? So we add 20's value. We add 20's value to our array. We then add 20's left and right nodes to our queue, and boom, we dequeue 20. We are now at the end of our for loop, so we append this array onto our all levels array, and we move up to the top of the while loop, right? So it was during our for loop that we created, or that we added all of the next level nodes onto our queue. And it's at the top of our while loop that we check. We say, what is do you have any values? If you do, set our queue length, set our snapshot of the amount of values of this level to whatever the length is of our queue. So we're at the top of our while loop again, right? And we say, does queue.length, or does the length of queue, is it not equal to 0? Yes, it is not equal to 0. It's equal to 2 again. So we set it as 2. We know that there's values to push for this level, so we create a new subarray. We reset our queue length to 2, and then we begin with our for loops. So we start with, we're going to iterate 2 times for our 2 nodes here, right? And we start with 15. So we add 15's value to our array, our subarray, and we add 15's left and right nodes to the queue as long as they are not null, but they are both null, so we don't do anything there. Then we delete 15 off of the queue, we dequeue it, and then we move on to the next iteration in our for loop, which is 7. So we add 7 to our subarray. We check to see if it has non-null left and right child nodes to add to the queue. It does not, they're both null. So then we pop out of our for loop and we append, or we push this array onto our all levels array. Then we go to the top of the while loop again. We're at the top of the while loop and we say, is queue's length not equal to 0? No, this time it is equal to 0. So we pop out of our while loop and we simply return our all levels array. And if you look at what we have up here, it's the same as the output down here, 3, 920, 15, 7. And there we go. So that's how we solve binary tree level order traversal using breadth first search. Now let's take a look at our space-time complexity. So our space-time complexity. Our space complexity is O of n. The reason it's O of n is because we have this array here that has literally every element in the tree, right? And not only that, we also have this queue that can hold up to 1/2 n plus 1 nodes at a time, right? 1/2 n plus 1 nodes is the potential size of the last level in a tree, right? So over here we have, let's say that 9 had 2 nodes. Then our last level has 4 nodes. Our entire tree has 7 nodes. So 7 plus 1 equals 8, divided by 2 equals 4. And so that is this equation here. And we know that we want to ignore lesser terms and ignore constants. So we do that and we're left with n either way. So both data structures are of O of n. For time complexity, we have a time complexity of O of n as well. And the reason for that is because we iterate or traverse every node in the tree. So as n grows in size, our time complexity, or the amount of time it takes to solve our algorithm, grows linearly with n. And there we go. So this is our time complexity, and this is how we conceptually solve this problem. Now let's go ahead, open up Leetcode, and solve this in both JavaScript and Python. All right, so let's solve this in JavaScript. The first thing we'll want to do is create our 2 data structures. So we'll create our outer array. We'll call that all levels. And then we will create our queue, which we will call queue, and it will be implemented using an array. And it won't be empty because we will add our root node to it. Okay, great. Now we'll open up a while loop. And we'll say while queue.length is greater than 0. If so, let's run the code inside here. And what we'll do is, since we know that queue has some values, we will create a level array. A level array, set that to an empty array. And we will also set our snapshot of queue.length. So we'll call that queue length equals queue.length, right? Now we can go into our for loop. So on this first iteration, on this first level, queue length is equal to 1. So this for loop will only run one time. So while I equals 0, or we have to let I equal 0, while I is less than q dot length, or q length rather. That's a very important distinction. I plus plus. Now, for each iteration, we want to do two things. We want to add our node's value to our level array, and we want to add our node's left and right nodes to our queue. So first things first is we need access to the node in question here. And the node in question in this particular instance would be 3. It would be our root node. How do we get that from our queue? What we can use is the dot shift method, and we will call that on queue. And so what this will return is it will return the first node, or the first element in our queue. And we will set that to a variable. You can call it whatever you want. I'm going to call it node. So let node equal queue dot shift. And what this is going to do for the rest of the array, or the rest of the queue, is it's going to, in place, remove the first element. So node, in this case, let's say that we had an array 1, 2, and 3. Okay, so we start up here with 1, 2, and 3. Q.shift is going to return 1, so node is equal to 1. Not an array of 1, just 1. And our Q is left as 2 and 3. So 1 got removed from it, and then the rest of the elements got shifted down 1 index. Okay, just wanted to make sure that that was mentioned. So let node equal q.shift, and then what we want to do is we want to add, we want to do our two things. We want to add to our level, we want to add level.push, we want to add our node.val. And this val, what is this val here? Well, this val is one of the 3 values that a node can have. So a node can have a value, it can have a left node and a right node. And there we go. So we push onto level our node value. Then we want to push onto our queue. We want to push what? Well, we want to push our node.left. And then we want to push our node.right. Our node.right. So queue push, node.right. But remember, we only want to push these to our queue if they are not null. So if node.left, which if node.left is null, then this will not get run. And we'll do the same with node.right. So if node.right, then we want to push node.right onto the queue. And there we go. So that's what we want to do inside each for loop. And after we're done iterating through all the different nodes in the for loop, we want to add our level array onto our all levels array. So we'll say all levels dot push, we will add level onto it. Okay, great. And the last thing we want to do is we want to return our all levels array. And that is pretty much it. Now there is one more thing that we have to do. In the case that root is equal to null, we want to have an edge case for that. We want to say if root is equal to null, return an empty array. So the reason that we have to implement this is because if we don't, we will push onto our level array node.val. But if node is null, then this is going to throw an error because you can't take a property of null. Null is not an object. It does not have any properties or values. All right, so that is it. Let's go ahead and submit that. Awesome. Let's go ahead and solve this in Python. So the first thing we want to do is we want to set our data structures, right? But before that, there actually is one more thing that we want to do. I did not mention this in the Blackboard, but if root is null, if a root, so in this case, our 3 up here is our root, but imagine it was null. Therefore, it was not an object. That is possibly what they will send as input, and so we will handle that. We will handle that edge case if not root, meaning if root is not a truthy value, we will return an empty array. So that's just something we have to do. Now let's create our data structures. So we will create our all levels array, and we will also create our queue, and we'll call it queue. So queue equals dq, which is a data structure, a double-ended queue from the collections module in Python. So we create this dq and we add root to it. Now we will open up our while loop. So while q is true, meaning while it has a length that is not 0, we will open up, or we'll create a new level, and we will set a snapshot of our current length, of the current length of our queue. So length equals length of queue, right? And now what we can do is we can open up our for loop. So this is going to be the for loop that runs inside our while loop, and it will run for the length of queue. So in this first case here, we have 3, right? And 3 is the only node in level 1. So therefore, when we want to set this at the beginning of our while loop, this value, queue length, so that it is equal to the appropriate amount of nodes in our level. And so it'll now only run one time. Even if we increment the size of queue as we will in this for loop, it will only still run one time, and then the nodes inside of the queue that are added using this for loop will be iterated through during the next for loop, during the next level, so to speak. So that's not correct, that is JavaScript. So for I in range of queue length, we want to get our node, we want to be able to access our node, and the way we do that is we pop it off the queue. So we say node equals queue.pop left, and because of the way we're inserting them, because of the way we will insert them, we want to pop left here instead of pop right, which is another function that we could call. But we pop left, and then we want to append the value of that node, so node.value, onto our level array. Okay. And after that, the second thing we want to do, the first is we just added our node value to our level array, and now we want to add our nodes left and right child nodes, the left and right child nodes of our node to the queue. So the way we'll do that is we will queue.append node.left. And we only want to do this, remember, we only want to do this when the node is not null. So we will say if node.left, meaning if node.left exists, queue.append node left. And we'll do the same thing for right. If node right, queue.append node right. Okay, there we go. So after this, we will run our for loop I amount of times, and we will then pop out of our for loop, and we want to we want to append onto our all levels array our level array for that particular level. And then finally, once Q is an empty array, or yeah, an empty queue, once Q is empty, we will be able to determine that there are no more nodes in the list below, or in the level below. So the level we had just pushed was the last level, and we can then return all levels. And just like that, we have solved this problem. Except for this runtime error. All level is not defined. Okay, all levels dot append. So let's see if it works this time. Awesome. So that's how we solve binary tree level order traversal in both JavaScript and Python.